In this video, we're going to go over all the things. We have a board that's pretty much ready to go. We think it's ready to go. I'm just going to go over a last check, show you how to add some little features, to clean some things up, to just verify some functionality right before the end, right before you send it off to Fab, to avoid issues in Fab and to avoid issues after Fab. So we want to be able to test this thing after it's done. So one thing I want to mention is that I don't have here right now is test points. Test points are one of the problems with surface mount components is it can be very difficult to access signals if they're just sort of buried under a solder mask on a circuit board. So through-hole stuff, if you have all through-hole components, it's easy. You can just put an alligator clip on the edge of a through-hole component. With surface mount design, it's much harder. And so if you don't specifically place pins that you can grab onto with an O-scope probe or a multimeter probe or something like that, you can end up in a situation where you have to really carefully put the tips of a very sharp multimeter probe or O-scope probe right on the edge of a resistor or something. It's a real pain. So generally what we want to do is we want to give ourselves an option for testing critical signals in our systems. Anything that we think something goes wrong, we're going to want to measure this signal and tune it or something like that. So especially since we have pots that are used to adjust signal, we're going to want to give ourselves an ability to test these. So I don't have test points in the components library. I think there's probably test points in the other library, but they're easy enough to find. We can just go to the manufacturer's part search, and again, if you don't have this, you can go to the panels button down in the bottom right corner and pull it back up. So I'm just going to search for test point. And what we're looking for is basically this. So it's just a single hole in the board that you can push a little pin through and solder it in, and then it doesn't even have to be soldered, I guess, but you can push a little pin in, and it gives you just a nice little mechanical connection to, and mechanical and electrical connection to an O-scope probe. So you can really hook this O-scope probe on, or hook the multimeter probe on, and kind of have it really hang on there solidly and measure that signal. So I'm just going to start sprinkling these in. So this one looks fine. We could choose any of these. Maybe there's one with a better 3D view. I don't know. We're not ultimately going to use this company's brand. Oh, look at that. That is nice. That's a pretty one. Yeah, that looks more like normal. This looks more like the ones we actually have. So let's place a bunch of these things. So we're gonna go. So where do we want to measure? Well, I probably want to measure. I definitely want to measure 5 volts. I probably the VBAT is probably easy enough to measure, but you know what? Let's measure. Let's measure VBAT and the switch bat just to be safe. It doesn't really kill us to add these extra test points right now. It's kind of free right now. It's easy to add these now. It's really hard to add them later. What else might we want to be able to measure? Oh, the boosted signal, we got that. VBAT, we got that. I'm not too worried about the USB input. Definitely want to measure this, the signal, the trigger signal. We definitely want to be able to measure that. What else? Maybe this signal. And definitely this signal. And definitely the offset signal. Definitely the pseudo ground. Okay, that's probably enough for now. So, so having done that, I'm going to update PCB design. What are these errors? Oh. So now we just gotta sprinkle these in. Sometimes if we didn't leave ourselves a lot of space, which I didn't, sometimes this can really screw us up. Oh, you know what? I also want to add a ground. So a ground test point is really important because it's kind of like what's relative. Everything else is relative to that. So let's go back. Place just one of these on just to find a ground somewhere. Where's a good ground? I'm being, I could just label it. I'm kind of being lazy here. Let's do that. Oh, I did it the hard way. C72 has no driving source. Oh yeah, I think it's just that's nothing. It's got an input, so it wants something with an output, which it ultimately this output is what's connected. Yeah, it's fine. I don't want to talk about it. I updated it already. There we go. Okay, so all right, let's sprinkle some test points around here, if we can. So this one is our ground test point. That one's fairly easy. We're just gonna plop it right there. Sometimes we can do this in 3D view, and it's okay. Test point 8 is pseudo ground. So this one's not gonna be fun, but we can make it happen. I'll show you how to make it happen. Doesn't like that. This dang part is gonna. Does that do anything? I don't know. Well, at least it kept me from moving it. Come on now. Come on now. All right, maybe I gotta give myself a little space. it actually okay with that? Barely fit it in somewhere where it doesn't throw a fit. Okay, we're gonna have to move that designator later. P7. Isn't this magical? What's happening here? Okay, well, it looks like it doesn't throw a fit about that. TP6. Oh, thank goodness. TP5. Maybe what we can do is not mess everything up. You know, it looks like we could put this here. And then, yeah. And run this. Sneaky, sneaky. Okay. And again, I should have probably done this as I should have left myself more space so I can do things like this fairly easily, but I didn't. So, oh, TP4. It looks like this one's pretty easy to do. TP2. Where's this? Oh yeah, VBAT. Yeah. Thing. You know, I think All right, after a sleep cycle, we're gonna finish off the rest of these. Actually, I think I was in the process of wanting to move. Whoa. Wanting to move this somewhere over here. Let's take advantage of this real estate we've got over here. So, battery. What's this one? 5E0. Here. Switched. There we go. Perfect. All right. Let's now we really got stuff crammed in here, right? It'll be okay. All right. So now let's clean up some of these labels because now the labels are all kind of a mess. I'm definitely going to want to switch my layer if I'm moving all these labels to clean everything up to top overlay. And sometimes I'll even do this in 3D view. So sometimes I find it's almost easier to... The problem is it's possible to... Ooh, I get my little battery label here. It's possible to accidentally grab the wrong thing in 3D view, so like that. You don't want to move apart, so and for me, I really rely on 3D view to see the labels because you get kind of a mess in here of all this junk that sort of gets in your field of view. Looks like Sig Offset's having an issue as his PS Ground. Oh, did I never route those? Oh yeah, maybe I never routed those. It would have told us eventually. Now I want to show you something too. See, like here where you have this C10 that's over this hole? That's not going to show up. So Silkscreen doesn't show up on copper, or Silkscreen only attaches to the solder mask. And there's a couple things we can do to fix this, and just in practice, it's good. It's good practice in general. We can basically the only time we need to not have these through holes covered with solder mask is if we intend to use them as an actual pin, if there's actually something soldered through them. If not, we can just what's called tenting, which is cover them with solder mask, just to show again, right? So this is what it looks like untented, right? You can see the copper. So what I'm going to do is I'm going to do find similar objects, and I'm going to just basically select everything that's a view. And then I'm going to go to properties, and I'm going to say annual tented top, tented bottom. Now let's take a look. Right now, look, it's covered. And it should be noted that this is not going to stay like this. It's going to get filled. This is ultimately going to get filled in with, you know, it's good. There's going to be a hole here. It's not like you can just float the solder mask on here. But it's, I mean, it is a nice feature to be able to tent it. People don't always want to. A lot of times people use them as test points. So a lot of times people use those holes as a test point. I like to tent. It's helpful for me. It makes it less likely for me to make an error too. So it's less likely I'm going to get a solder bridge happening like under a chip or something like that if I tent. So okay, what else? So we've done a lot of fiddling with this and we've had things shift. So I'm just going to one more time just do design rule check. All right, so it still looks like we're good here. Maybe it's time for it. Save all. Okay, and the Silkscreen looks okay. It's not great. I mean, we could spend a lot of time. We could. I mean, you know me. I could spend 20 hours on this apparently, but we don't have to. Let's do board outline. So, but right now, you know, I set my limit. So your board could be this big. Do not cram your board into something this tiny. Your board could take up this entire space, but basically this initial perimeter we made was to keep ourselves to this 100 millimeter by 100 millimeter limit, just so we knew the boundaries we had to work with. But now that we've got this board as is pretty much done, let's do our actual board outline. So here's something to keep in mind though. In Altium, board outlines don't generally play nice. So Altium doesn't. The board outline as defined in Altium isn't really useful in terms of fabricating. So a lot of times we can do a board outline out of a particular, we can, you know, define the board outline, but we're probably going to have to anyway create a layer that has the definition for the board outline just so we can export it for the purposes of fabrication. So when I do a board outline, I usually don't worry about it being an outline, and I just pick a mechanical layer. So I will pick something, I will pick a mechanical layer that I don't think I'm using, like mechanical 12 or whatever. And actually there's a way to find it. So we can do, find similar objects and just, so if we choose our layer to be, what was I going to do? Mechanical 12? So I'm just looking for anything with mechanical 12. And it can't find any. So we'll use mechanical 12 for now. And so we're going to basically just draw our board outline right now. And so I'm going to so switch to mechanical 12, and I'm just going to place a line. And this is usually where having a nice coarse grid is really helpful. So I'm going to hit the G key, set my grid to like 50 mil. Set my grid to set my grid to 25 mil. And I'm going to not do this. I'm going to start here. And I'm going to I'm gonna do a rounded edge here. So I'm gonna do this board with a rounded edge. So I'm gonna hold down the shift key and hit space, and that goes to my options. So I'm gonna space until I get to this 90-degree rounded edge. And then, yeah, I'm just gonna click it. And I'm gonna notice my radius is 2 of these, so my radius now is 50 mil. So I like rounded edges on boards. Now you see this, if it does it in the wrong direction, you can hit the space bar and it flips the orientation of that. So. Oh no. So I think if you hit delete, it goes back a step now. Okay, well, I messed that up a little bit. I forget how to backtrack. There is a code to backtrack. So I want it to be here. Now watch what I'm going to do here. This is a fun trick. I like doing this. See, I see that my switch here, it defines sort of the orientation of the switch. And what I'm going to do is I'm going to do a little of this action. See what I did there? Okay, so what I did there is I made a little cutout in the board. So basically this switch, if the switch doesn't extend past the actual board outline, but we have a little cutout so you can get your finger in there, so you can get a fingernail in there to switch it. And this protects the switch, so the switch doesn't get bumped. But it still gives you the ability to kind of switch, right? So, and it won't be able to cut this precisely. So the board outline is cut by a mill, so it's, you know, it's not actually going to be a nice sharp interior angle. I also want to, I think I want to cut out a hole here also, a hole in the board for air to flow. So I'm going to set my grid to something else. This is not great. I think I moved the sharp sensor kind of anyway. So if I'm trying to make kind of a hole, well, there's a couple ways to make a hole. One thing we can do is, we can place a circle. Let's try the arc edge here. And let's just do it. We don't have to have the hole be quite as big as this. This is not the perfect way to do this, but oops. I don't think I want to do this. I think I do want to do a full circle. And I think this wants the center. We're trying to get to the center. It looks like it's near. And it looks like it's... This will be close enough. Okay, so now I have defined my board outline and a little hole in my board. You can do holes drilled too, but there's a limit to the drill size. So the board cut is imprecise. The drill position is precise. So drill holes are usually limited to like 1/4 inch. This is bigger than 1/4 inch. So it has to be cut out like a board cutout. So now what I'm going to do is, so I know this was my mechanical 12 layer. I'm going to do click on part of it and do find similar objects, and I'm going to find everything on 12. So I'm going to say anything. It doesn't matter if it's a track or a curve or whatever. Anything as long as it's on 12. So and that gets this whole board shape that I had defined. And I knew it's only going to get that because there was nothing else using that mechanical layer. So now I can go design board shape and I can go define from selected objects. Now all that did was that just did it in Altium. So that just Altium just defined it that way. Also note that Altium doesn't do a board cutout. Altium doesn't. You can define a board cutout, but it didn't. It just took the exterior perimeter of what I selected. But the fab should know that this means that it's going to cut out a hole internally in this thing. So now let's look at the 3D view, though. Because look at this. This is looking nice. Okay, it's looking sweet. Now, we want to do some text. So we got nothing on the back right now. So let's do some text. Let's do some text on the back. So I'm going to say this is John's sensor. You got to put your name on something. Ever since humanity first discovered rocks, they were putting their names on the rocks, right? This is John's rock. So let's make John's rock. So I want to put this on the back. So I'm going to switch my layer to bottom overlay. It should be bottom overlay. Yeah. Now the thing is, when I'm putting text on the bottom, it's going to be kind of reversed. So one neat thing I can do is when in my view, I can just do view flip board. Boop. Now I'm looking at the back of the board. So now all my text looks backwards. But if I'm writing text on the back of the board, it's going to be nice and handy. So I'm going to place a string. And I'm going to hit tab to change what this is. This is going to be John Lund. Now it's showing up as reversed, which means, oh yeah, I want to mirror it. And now I want it to be fatter than that. I want a nice fluffy John Lund here. 16 mil. Yes. Yes, and I don't like the font. I want do true type font. What's my favorite? Impact. They have impact. Oh, that got impact. Yes, yes, impactful. Boom. Look at that. Not 60 mil. 100 mil. Not. No. 200. Boom. Look at that. Talk about impact. Set my grid a little coarser. I don't need to be so. John Lund. Gotta have a slogan. What's your slogan? Featuring Macy Gray. Is it AY or EY? Uh-oh. Okay, Google, how do you spell Macy Gray? How do you spell Macy Gray?
Macy Gray is spelled M-A-C-Y-G-R-A-Y.
Whatever. I'm getting silly with it now. Okay, but you see, right? We're going to add text. And then if we go to the 3D view, right, now we can see, right, now we can see that nice text on the back there. So a lot of times it's nice to put a box that you can actually like write on with ink, you know, if you want to do so quite often people will do like you can place a string and like revision, right? So you can do revision, and then you can just like place like a fill. Oops. Right. So now we have this big revision here. So we can write with ink on this, and it works out okay. All right, so that's looking pretty good. I'm feeling pretty good about this. Let's just do, because stuff moved around, let's do one final design rule check. Everything's looking good. All right, save all. Okay, now let's export this. Let's actually fabricate this. We've designed the board, we got everything. We want to keep in mind that layer 12 was our board outline. Let's do file, fabrication outputs, Gerber, X2 files. I think. Ooh, this is different. We want to do Gerber. Sorry, not Gerber X2. So inches is fine. 2.5 should be fine. Now this is the layers. So top overlay, we don't need the paste layer. Top solder, top layer. That's the copper. Bottom layer, bottom solder, bottom overlay. So what are these? Top overlay is the top silkscreen. Top paste is it defines the openings in the it defines where paste should go if you're doing a paste stencil. We're not going to do stencils for this class, but if you were exporting, if you did want to be able to do a stencil to stencil solder paste on the surface, you'd want to export this top paste layer and then send this top paste layer off to like a fabrication facility, or to like a stencil manufacturer, which is usually, sometimes, most places that do PCB will also do stencils, but we're not going to do the paste for now. And then we also want to export that mechanical 12 because that was our board outline. So we have 1, 2, 3, 4, 5, 6, 7. So 7 layer files, outline, and then on the top and the bottom there's 3 layers each. There's the layer that defines the copper, the layer that defines the silkscreen, and the layer that defines the solder mask. So that's silkscreen, solder mask, copper. Copper, solder mask, silkscreen. So, and then our board outline is 12. And then, okay. And then this shows us a view of these Gerber files. I don't like that I didn't notice that U3 was there until just now. How did I miss that? I don't particularly care. Okay. But okay, so I'm gonna do it again. That's why we check. Fabrication outputs, Gerber files. It should have saved all of our settings. Okay, that looks better. So again, yeah, the text looks looks backwards because this is showing us our board is flipped. If we want to go back and unflip our board, we can. We can go and view flip board around again. So, but just note that the text will show up as reversed when it's the back, because it is reversed, right? We're just seeing through it. It's like an X-ray image. And we can look over this. Sometimes you can kind of get a little better view, make sure everything's okay, looking over this design. A couple things to note. Altium doesn't always freak out if your copper is close to your board edge, but you want to make sure the copper stays away from the board edge. The fab will usually get mad if the copper is close to the board edge. So yeah. Yeah, there's a couple things I would have gone back here and fixed. Like sometimes you see the ugliness of your design when you're doing this. I probably would have gone and fixed some of that stuff, but I didn't. So it is what it is. Okay. All right, we still have more work to do. So we just exported the layers. We also have to export the drill holes. So we also want to export our fabrication outputs, NC drill files. So we want to keep this the same as it was with the other one. So the other one was 2 to 5, so we're going to do 2 to 5. I tend to like keep leading and trailing zeros. Just when it produces numbers in a text document, keeping leading and trailing zeros just shows that in fact the number had zeros there instead of uncertainty. I don't know. I always keep it. It doesn't really matter how you reference it. No. None of this really matters because you shouldn't be using slots. Try not to use slots. If you're using a component that has slots, use a different component because I don't want to mess with slots. So yeah, this all should be good. What's going to happen is so the drill file shows the coordinates of each drill hole and the size of the drill hole. And it's set up to basically be read directly by the machine that does the drilling. Most fabs though, because it's going to be your board and a bunch of others on the same giant piece of fiberglass. So normally they don't care what order your holes are in. They're going to reorder, they're going to optimize their own drill pattern. All they need is where do my holes have to be and what size do they have to be. So this should work okay. Okay, so that's our drill holes. Sometimes we can see if something's a little off here. So, okay, so now what we're going to do is we're going to go to our project folder, and all of this should have been exported to the project folder, into the project outputs. And there's a bunch of extra junk too that we didn't necessarily need. But one thing I like to do is I like to go view, and I like to file name extensions to be able to see these. First thing I'm going to do is this layer 12, which is our board outline. I'm going to rename this GKO. And that will tell the fab that this is the file that defines the outline of our board. Then I'm going to select I have 8 files I need to select. Hold down the control key, bottom layer, bottom overlay, bottom silk. Keep out board outline. Top layer, top overlay, top silk. And then this text file. This text file is our drill hole design. And then I'm going to send this to a compressed zip folder, and I'm going to change the name. So everybody's this is the name of these files is the default template name so everybody's, unless they change it, everybody will have these same default file names. But it's no use to me if you send me a file for fab that has like 2-layer PCB template. That doesn't help me at all. So I'm going to call it Lund for now. Just call it Lund. Now this should have all the files we need to tell the fab what we're going to do. I always like to check OshPark is a great place to fabricate small batches of boards. They have really good production. So like the board you get back from them is like a finished production quality board. It's gold and everything. For this class, we don't normally use it. You can send yours into them. I like using it to check, to do my error check. So I'm gonna go to OshPark. I'm gonna take my zip file and I'm gonna upload it. And I kind of let OshPark's processor, and sometimes I'll buy it from them. I don't want to say like I just use their scan check to see if everything works, but it's a good verification. So so they say we corrected the drill precision. Oh, they don't see that as a hole in the board. Maybe they do. Oh well, if they don't see it as a hole, they don't see it as a hole. Maybe they do. I don't know. I'm worried now. I might have to come back and do an edited version to get the hole cut out. They should recognize the hole as being a hole in the board. Well, now I'm worried though. But all right. So this gives us another chance to look. But this passed. So this looks like it passed inspection. So now the thing to note though is it is 47.3 by 65 millimeters. So I like to use that. So I'm going to go back and I am going to change my file. And I'm going to say 47. So I'm going to round up. I'll say 48 millimeters by 65 millimeters. And then I'm going to specify what color I want. So the colors that are cheap are red, green, black, but I don't like black. Don't do black. It has problems in the oven. So red, green, yellow, blue. So we can pick a color, red, green, yellow, or blue. I kind of like the it's Western. Let's do blue. Okay. So this is what I want you to do for your fab file when you send it to me. Is I want you to export following the process we just did. I want you to name it like this. Name it. Put your last name. Put the dimensions, rounding up. Put the dimensions of the board in millimeter. Say the color you want. Again, choosing from the cheap options. If you say like I want purple or I want like glow in the dark, I'm just gonna just pick a different color for you because I'm not gonna pay for that. If you want to, you can buy it through Osh Park, right? This would have cost me $23, which is not too bad with free shipping. It's actually very reasonable. You get 3 boards and it's gold plated. It's fantastic. So, but you know, when you send it to me for the ones that I buy from China, it should be structured like this. If you don't structure the file name like this, it's a huge time-consuming step for me and Reza to fix that for 30 students. So please follow these instructions. If you don't, it might delay your board order going out, and also not checking this might delay your board order going out. So I want to make sure that that everybody's board gets out, is successful, works okay. All right. Oh, one thing to note: if for instance, you didn't have Silkscreen on the bottom, on the back layer of the board, it's gonna kind of throw a fit. It's gonna say, you know, I didn't see any Silkscreen. I didn't see any. You sent me an empty file for the Silkscreen on the back of the board. That's probably okay, but it does add some uncertainty. So it's good to just put something on the back. Put something with Silkscreen on the back, just so it doesn't throw a fit about that. And then that's it. So this all looks good. This is our introduction to Altium. So what you would do then, if you got this finished, you tested this, you'd have this design file. You would then you would submit this zip file as your assignment in Canvas. So in Canvas, we have this board assignment that's due on Friday at 1 p.m. So you would basically go through this process, watch 6 hours of videos, design your circuit, build your circuit, have this board zipped up and labeled like this, submitted as an assignment by, I think it's noon or 1 p.m. is the due date. There's a reason for that. It's so that Reza and I can get the boards out to China. China goes to sleep, right? They got to sleep too, I think. And so we send the boards out to them before they go to bed. So that way, before Reza goes to bed and before China goes to bed, they can say, hey, your designs are messed up, or hey, your designs aren't messed up. And then we can get it out the door. We can get it going. We can get the noodles in the pot and boiling before the weekend. So thank you, everybody. It's been long, but this is the video. This is the start to finish, clean computer, some mistakes along the way, crash course on Altium and outputting for fabrication. And one of the things I want people to take away is this isn't that tough. It might seem a little weird because it's the first time going through it, but this is a fairly easy process. It's not that tough to take a design and make a board and have it fabricated. And you know, you're really close. It's easy when you're going through school to think, oh, I'll never be able to do the stuff that I see other people do. But sometimes it's just because you've never seen it. And so partially the purpose of this class, a lot of what you do for this assignment is going to feel cookie cutter. But it's okay. This is really just getting you to go through the steps once before your senior project, to know how it's done, to know how easy it is, and to just know you can do it. So hopefully everybody has a good experience with their board. If they don't, you can feel free to ask questions about it. Hopefully you can get started maybe early. I don't know. You got a lot of stuff going on next week for this class, but you can send me questions. You know, biggest thing, save often. Keep your backup files. I don't want catastrophes where people lose everything. So back things up. Don't back things up on thumb drives, right? They fail, right? Or have multiple backups if you need it. So don't ruin your project. And thanks for watching the show.